Okay, so for today, we will talk about the kinematics. Yeah, this is part one from the second part, two part of kinematics. Yeah, today we will talk only about the KLB, if you remember from your high school physics class. Yeah. So today we will talk about kinematics, and then we will review a little bit about factor. And for the last part, it's a Unity hands-on. Yeah. For the Unity hands-on, I actually have uploaded it to YouTube, and the link will be available. Let me see. On your classroom, I have scheduled the. Oh, sorry, I missed the YouTube link. I will provide it later. Yeah, after the second part. Yeah. So we will talk about kinematics, the introduction, and then we will review about the factor, and the last part you will have to try yourself for the KLB using Unity 2D. Okay, let's talk about kinematics first. Kinematics is a field on physics which studies the object movement, and we will disregard any forces that might influence the object. Yeah, so this is the simplification of any object's movement. Yeah, in real life, an object may move and be influenced with some forces. Yeah, for example, like push force and another force, yeah, gravity as well. Yeah, but for kinematics, we will simplify. We will only look at the movement of the object. Yeah, so we only focus on position, velocity, and acceleration as well. Yeah, and also we will assume that objects are in particles. Yeah, so even if the equations later will say that a car moves or maybe a truck moves or somebody moves, yeah, we will assume that the car, the truck, and the people, yeah, is or are particles. Yeah, to simplify things further. Yeah, so linear motion can be divided into two parts. Yeah, the first one is when the object moves with uniform v. In Indonesia, we know it as Gerak Lurus Beraturan or GLB. Yeah, the second one, if the object moves with a non-uniform v, yeah, then that means an acceleration a exists. Yeah, we can also divide this movement into two kinds. Yeah, the first one is uniform a. We know it as Gerak Lurus Berubah Beraturan or GLBB for short. Yeah, and the second one is a non-uniform A. Yeah, we won't study this in PBA, so we will only study GLB, GLBB, and combinations of them. Yeah, in English, I think we don't have a direct translation of GLB and GLBB, so I will use the Indonesian term, yeah, GLB and GLBB instead. Yeah, the closest term I can find of is GLB is a uniform speed and GLBB is uniform acceleration. For today's class, we will only talk about GLB, so I think this topic is easy for you. Yeah, we will take a look at GLB. Yeah, it's simply moving objects performs GLB when it moves with a constant speed. Yeah, so the keyword here is speed. Yeah, but if we translate it into Indonesian or bahasa Indonesia, yeah, does it mean solely kecepatan? Yeah, let's take a look. So in everyday English and even in bahasa Indonesia, yeah, there are no direct difference between the speed and velocity. Yeah, usually when we talk about how fast or how slow an object moves, we will refer to as speed. Yeah, so speed and velocity is the same here. If I input the two terms into Google Translate, Google will translate them both to kecepatan. Yeah, so in everyday conversation, we regard the speed and velocity as the same term. Yeah, but in physics, actually they are different. Yeah, speed is not the same as velocity. Yeah, one difference is speed is a scalar quantity, while velocity is a vector quantity. Yeah, what is a scalar quantity? Yeah, here I have provided one definition from Britannica. Yeah, scalar, a physical quantity that is completely described by its magnitude. Yeah, the example here is volume, density, speed, temperature, energy, mass, time, and so on. Yeah, in the meantime, velocity as a vector, we will review about vector in a short while, yeah, later on. So velocity needs direction. In bahasa Indonesia, we translate speed as kelajuan and velocity as kecepatan. Yeah, so in physics they are not the same. Yeah, but for everyday use, you can use speed or velocity. I think people um, more frequently use speed instead of velocity. Yeah. Okay, so the correct definition of speed and velocity. Yeah, here speed is defined as distance over time. Yeah, that means how much distance an object can cover from one place to another. Meanwhile, the velocity is described as displacement over time, yeah, the rate at which an object changes its position. Yeah, maybe it's better if I give you an example. So, if I have an object A moves from um, an object moves from A into B, yeah, but it follows this kind of movement, yeah, a little bit erratic, but it let's assume it moves like this. Yeah, so the blue line represents the distance that the object has traveled for this distance, but the displacement is simply a straight line from A to B. Yeah, so distance may not be the same as displacement. Another term we will talk about is an average speed or average velocity. Yeah, it means that an object's speed or velocity which is observed in the entirety, yeah, from the moment the object moves until it completely stops. Yeah, because it is an average speed or average velocity, we cannot conclude if the object actually moves in a constant velocity or not. Yeah, we only care about the average from the beginning the object moves until the end, yeah, when the object stops completely. Yeah, so average speed is denoted by v, yeah, v velocity, but it is an average, yeah, equals to the distance over time. Yeah, meanwhile, for the average velocity, we will denote it as v with a vector, yeah, an arrow above the v, and we draw a straight line above the arrow. Yeah, the straight line denotes the average. Yeah, the average velocity is defined by the displacement over time. Yeah, so average speed is distance over time. Average velocity is displacement over time. Yeah, that's why the s here is a vector as well. Okay, for example, I have a car that circles around a track race of 1 kilometer. It arrives at the finish line in 50 seconds. Please calculate its average speed and average velocity. Yeah, I will give you a moment to think. Yeah, how to calculate its average speed and average velocity. Okay, so if I illustrate the movement of this car, let me draw it here. Yeah, let's say I have the circular track like this. Oops, sorry. Please assume that it is a circle. Yeah, a perfect circle. And let's say that the start line and finish is over here. Yeah, I have a car. Let me draw it using another color. Yeah, assume this is a car. Yeah, and then the track is 1 kilometer. Yeah, 1 kilometer, or it is the same as 1,000 meters. Yeah, the car moves from the starting point to the finish line. Please assume that the both circles are the same. Yeah, it moves or it travels from the finish, from the start to finish in 50 seconds. Yeah. So yeah, you are correct that the average speed is 1 kilometer over. Let me let me correct my writing first. Yeah, the average speed is correct. 1 kilometer over 50 seconds, or 1,000 meter over 50 seconds, which is 20. Yeah, 20 meter per seconds. Yeah, in the meantime, the average, yeah, the average velocity is actually 0. Yeah, why do you think it's 0? Yeah, please observe the starting point of the car, yeah, versus the finish point when the car actually stops. Yeah, where the car moves. Yeah, where does the car move? Over here, right? Yes.
It's the same position, sir.
Yes, you are correct. So A and B is actually in the same position. Yeah, so if you subtract them to find the displacement, then you will get this
Zero.
0. Yeah, that's why the average velocity is actually 0 meter per second. Yeah, is it clear for you? Any questions to differ, to be able to differentiate between average speed and average velocity?
Clear, sir.
Okay, nice. Yeah, so here the calculations. Average speed is 1,000 meter divided by 50 seconds, so you get 20 meter per second. But for the average velocity, it's actually 0 meter per second. Yeah. Please be aware about the units. Yeah, if you type in 1 kilometer per 50 seconds, you will get something like 0.02 kilometer per second. Yeah. But for convenience, let's just use the SE unit. Yeah, SI unit, which is a meter per second. Okay, let's do some exercises. Yeah, the number one. Let's say on Sunday, a school organized a round trip from city A to city B, which is 240 kilometer apart. Yeah, from A to B, the speed of our bus. Yeah, let's say they go from A to B by bus. The speed was 40 kilometer per hour. A lunch break then follows for 2 hours at B. And then on the way home from B to A, the speed was 60 kilometer per hour. Yeah, please calculate the average speed and average velocity for this trip. Yeah, again, if you have difficulties to differentiate between average speed and average velocity, it is wise to just draw the diagram representing the movement of the case. Yeah, I'll give you another time to think of this exercise, then later we will discuss it. Yeah. For this question, yeah, it is best if we draw it Let's see. Can I? Okay, I will just clean my canvas to draw this case here. This is for number one. We have the information that from the city A, from and city B, sorry, the distance is 240 kilometers, yeah. And then for the first trip, okay, this is the first trip from A to B. It requires, or the speed is, let me check. The speed is 40 kilometer per hour, yeah. We have the speed here 40 kilometer per hour. So that means the time taken from A to B is 240
6
kilometer
hours.
divided by 40 kilometer per hour is 6 hours, yeah. Okay, so we have this information from A to B. It took 6 hours, yeah, to move in 40 kilometer per hour. Okay, and then the next sentence, a lunch break then followed for 2 hours. Yeah, the second movement, yeah, we have actually the second movement, which is happens in the CTP. Yeah, the velocity is actually 0 kilometer per hour because they does not move, and they reside for 2 hours. Yeah, so basically here the distance traveled is also 0 kilometer. Yeah, v times t, 0 times 2 hours, you get 0 kilometer. Yeah, and then the third movement is from B to A. Yeah, the time taken, oh sorry, the speed from A to B was 60. Okay, let's write it down here, 60 kilometer per hour. So the time needed to move from B to A is 240 divided by 60 is per hours, yeah. Okay, now let's summarize all of them, yeah, because we need to calculate the average speed here. We have the total time is actually 6 plus 2 plus 4, which equals to 12 hours. Yeah, and then the total distance is 240 from A to B plus 0 because they have a break at B, does not move. Yeah, and then from B to A, we have also 240, which equals to 480 kilometer. Yeah, thus we have the average velocity equals to 480 divided by 12, which is 480 divided by 12, 40 kilometers per hour. Yeah, so this is the answer. Yeah, so Naufal, I think you are almost correct, but you forgot about the second movement. Yeah.
Yes, sir.
Okay, what about the average velocity? What is the displacement of this case? Yeah, if you summarize the displacement from the first up to the third movement, you will get what?
0.
0. Yes, so the average velocity again here is 0. Because if you summarize these three movements, actually it appears that they do not move here from A to B, then they don't move from at B, then they go back from B to A. Yeah, so the final displacement is actually in the same position. Yeah, that's why the average velocity is 0. Yeah, any questions maybe? Not yet. Okay. Yeah, so I think for the second question, this is quite similar to the first question. Yeah, on the racing competition, each participant must run for 25 meters while carrying a neck on a spoon, then go back to the starting line. Yeah, we have Uchok here. He managed to finish his first 25 meter in 20 seconds. Yeah, on his way back, he gained more confidence and finished in 15 seconds. So, how much is his average velocity for the first 25 meter? You don't need to really calculate it because I think the result is quite ugly. Yeah, just tell me how do you calculate the average velocity for the first 25 meter? 25 divided by 20. Okay, 25 meter divided by 20. Yeah, that's correct. What about the last 25 meter? Yeah, the second trip.
Divided by 15.
Sorry, 0.
I guess it's 24 divided by 50.
25 divided by 15.
Yes, correct. It is 25 divided by 15. Yeah, but because this is a velocity, so you need to append a negative to your 25. Yeah, let's assume that the positive value moves to the right. Yeah, so if you draw, let me draw it again here. Okay, so I have the point A here and point B here, and let's assume that the positive directs this way. Yeah, for the first strip, we have A to B, so the direction is positive. That's why the average velocity is 25 meter. Yeah, 25 meter divided by 20 seconds. Yeah, but for the second trip, we Ucok goes from B to A, so the displacement is actually negative. Yeah, so his average velocity is negative 25 meter divided by 15 seconds. Yeah, and then for the third part, which is his round trip, yeah, it's easy. The average velocity is actually, oh,
Zero.
sorry, I misplaced the notation. Yeah, okay, the average velocity is 0, yeah, here. Okay, factor first, then the average, yeah. V factor average. Yeah, so be careful about velocity because it is a vector. Yeah, it does have the direction. That's why for the last 25 meter, his velocity is negative 25 meter over 15 seconds. For the average speed, I think you can calculate it on your own, yeah? Okay, so with these exercises, I hope you understand the difference between average speed and average velocity. Any questions, maybe?
No,
All good?
Yes, sir.
Okay, nice.
sir, sorry, sir. EME have unstable connection.
Yes, sorry. I can't hear you,
EME
Naufal. Or should I
have
call
bad
you Faros
connection.
and Musyafa?
Yes, sir.
Because
Yes,
both your first name is Naufal.
yes. You can
Yes,
call
sir.
me
You
Faraz.
can.
Okay, so Faras, do you want to ask something, maybe?
I just want to inform you that EME have bad connection, sir. EME
Sorry, I cannot hear you.
EME have bad connection, sir.
Oh, okay. Yeah, Yemima.
Yes, sir.
I saw her disconnected, then connected here for some time. So yeah, I think it's best for her to catch this class later. Yeah, I will upload this uh, recording to YouTube later.
Okay, sir. Thank
Okay,
you.
next continue then. So how do we implement this KLP into games? Yeah. On games, velocity is commonly used to move an object somewhere. Yeah, it is obvious. The direction it moves is determined from the direction of its velocity. Yeah, so let's review the vector for now. Yeah, but not vector. Yeah, we will talk about vector.